Okay, I guess we can start now. Shall we proceed, Ankita? Good morning, everyone. I hope my voice is audible and screen is
Yeah,
visible
good
as well.
morning.
Yes, good
Yep.
morning.
Yeah,
Good
so
morning.
let's start. On the screen is the agenda that we decided for today. One of the structural pattern which is pending from the last session. That's where our session is going to start with. The pattern is proxy pattern, and then we'll be starting with behavioral patterns. And some of the behavioral patterns we'll be discussing today, which include chain of responsibility, command, interpreter, iterator, and mediator patterns. Okay, so before we actually start with the agenda for the day, I just wanted to understand like whatever the patterns that we have discussed so far. At the very atomic level, you have understood all the patterns and you know exactly when and where the pattern comes into picture. Is it?
Yes,
Okay, now here we are not looking at the larger picture because each pattern probably may not be required every time. There are very specific cases where we need to be aware of the available patterns and which of the patterns would be applicable in which scenario. And that comes with more and more experience when we work at the architecture level, right? It's not a pre-decided path that, okay, whenever you are doing this, do this or use this pattern, correct?
yes,
Also, at the same time, when you are working with the frameworks, maybe Java based frameworks, maybe .NET framework or any other framework, there are many of these patterns which are already implemented at the framework level itself. So knowingly or unknowingly, you keep on using some of these patterns already, correct? Behind the scenes, your code probably depends on or uses these patterns already. You may not actually require to think about the patterns all the time. Yeah, if you are looking to build a framework of your own, which may be domain specific, business specific, you might need to actually focus on the implementation of patterns at times, right?
Yep. And Saket, can we also cover
Yeah,
CQRS pattern in .NET Core?
sure, sure. We will include that and let's see where it would be the right place to include that. I'll just make a note of it. Okay.
Yeah. Yeah. Thanks. Thank you.
Okay. So let's start with the proxy pattern first of all, the last pattern in structural patterns. In general, we are very well aware of the term proxy, aren't we? It all starts from school and college days only when we mark the attendance on behalf of some of the friend who is not present actually, right? So not everyone does that, but yeah, this is pretty common. Yes or no? That's where the term proxy
yes,
basically comes in first of all. So this example itself has got some input about what proxy is. Yes or no?
Yep.
yes,
Think of people like object. One object is something which is being communicated but not available. There is another object which is probably providing the communication. on behalf of the first object. There could be some message which needs to be passed on to the actual object. It may go via the other object also. Sometimes this helps in controlling what message should go, what message should not go, right? When it comes to the software, when it comes to the client server applications, this become even more important. While working with client server pattern, when the client is trying to communicate with the server, the client need not know the intrinsic details of the server implementation all the time. In fact, for code security reasons, the client should never know the intrinsic details of the server at all. Only the publicly visible interface should be available with the client. Yes. I
Yes.
mean, what the service has got, what operations it has got, and where it is available. Apart from this, there is nothing else that need to be known to the client. Correct? Like when you apply for a passport, you interact with some front desk people where you submit your documentation, get it scrutinized in one or two or three levels, and that's it. What happens behind scenes after that, until and unless you receive your passport, is none of your business. And actually, you need not know how and when the processing is done. Who does that processing? Am I right?
Yes.
It is the passport office which will take care of all the behind the scenes activities. So in this case, we can consider the passport office as the server application and the front desk probably as the proxy for it. These days, the first front desk where you submit your documentation is usually an outsourced agency, right? Which does the document collection, which does the first level of scrutiny, clicks the photographs and all, verifies the documents with the original documents and all, and then accepts it. Correct?
Yes.
Now, there also, you actually need not know what is going beyond that. Interacting with the proxy. Passport website also, if you are trying to use, that is a kind of a proxy to the entire passport office system only. Yes or no? Where you can track at what level my passport application is. Am I right?
Yes.
So whenever you need to interact, these are the two proxies where you can put your request to see what has happened with my application or where my application stands. These are not the passport office themselves. They are just representatives. And we can say these are proxies. So that makes your actual implementation hidden from or encapsulated from the end user completely. You just have the externally visible interface and nothing beyond that. In client server programming also, while providing the proxy, most likely we share some sort of abstraction, which may be abstract class, which may be an interface with the client and not the actual service implementation itself, right? We create the client library or client SDK. What does that mean? That client library or client SDK is nothing but the set of proxies only to interact with the server objects. Am I right?
Yes.
So that is what actually the proxy pattern is all about. If we look at the definition, we can say the proxy design pattern actually provides a surrogate or a placeholder or representative of another object to control the access to it. Herein we can introduce some sort of authentication and authorization practices as well, where we can actually check if the client is allowed to proceed with the call or not. If not, we can block the call there and there itself at the client level only. Am I right?
Yes.
Have a look at this diagram. Client, there is a object which actually needs to be communicated. So there is a representation of it. Actually, there is a proxy. Probably this is the object which holds the data. And then there is a proxy which actually provides the operation on it, where only the interface of that operation is present here. And the actual object resides over here, which contains a concrete implementation. So the client need not know what is the real subject or real object in this case. Am I right? On the other hand, probably proxy knows where the service exists and where the call needs to be provided. And before doing that, it has got all the authority of filtering the request based on authentication, authorization, and other parameters, right? So suppose we are looking for a calculator service. Your subject will be the interface or the abstract class representing the maths operations. Add, subtract, multiply, divide, etc. So let's assume in .NET we have an interface called as iMath, which contains the declarations of all these methods. Your proxy will be simply a class which implements this interface and has got some of its own code to do all the verification of the client and proceed with the actual call with the server, right? And when I say server, server will be the concrete math class object, maybe math or real math, something like that, which implements iMath and contains the actual calculations. Is that clear?
Socket
Yeah,
uh, means whichever the proxy having that
yeah.
implementation and the server side implementation is the same one, or there is a
No, proxy will be just making the call to the server side implementation. It won't be same.
okay.
Looking at the interface of proxy and the server side implementation, it may look exactly same, but the composition of code within both proxy and the server side implementation will be different. Proxy will be all about the checks, verifications, and then proceed with the actual call to the server. Understand?
Okay.
Like if you put some application to Prime Minister office, do you really think that your message, your application reaches the Prime Minister's table directly?
Mm,
It doesn't, right?
yeah.
It
Yes.
first of all goes through the Prime Minister office, multiple desks or basically the designated officers who basically scrutinize and see which application seems to be legitimate, do all the verification at their end, and then if they find that okay, this is something which need to be known by Prime Minister, it reaches Prime Minister, right?
Yes.
They share it on your behalf. You don't, your mail or your message or your application, physical application doesn't reach the Prime Minister's table directly. You always address it to PMO, not Prime Minister, correct?
Yes.
And I believe Prime Minister's address or Prime Minister's email ID is never published anywhere to the public. There is PMO ID, PMO address only all the time, correct?
Yes.
So here, what this PMO is, group of people who are working in the Prime Minister's office and proxying Prime Minister, correct? So they are not the decision makers, but they are authorized to do all the verification of the incoming mails, messages, letters, applications, etc., and decide on what should reach Prime Minister, on which the actual decision will be taken by Prime Minister only, right?
Right.
So this is the same thing what proxy does. Proxy will
Means
hold information about where the service is and how do I reach there so that the call can be made. Correct?
yes.
So return A plus B statement won't be the part of proxy. It will be on server only. Whereas proxy will say server dot add and pass the two parameters to it to get the two numbers added. Got my point?
Okay, got it.
As if you only are calling it, but if you directly call it, there is no security, there is no check, there is no verification, right? Whereas if you do via proxy, in that case, there will be a verification, there will be a check in between, and if all found good and satisfactory, then only the proxy will forward your message to the actual server. Understand?
Yes. Means might be this is maybe I'm wrong. Just want to
Yeah.
know means our .NET Core is having kind of middlewares and filters as well. Means
Yes,
uh,
correct.
yeah, so that is kind of means we can say it is a proxy because we are doing verification, authentication, authorization
Mhm.
before actually hitting the endpoint. So is it resemble to this as
Not exactly like a proxy. That is something like an additional functionality which might be used by the proxy.
okay,
So those are additional code, right? Which you are chaining into your request when it comes to the
okay,
middlewares. That
okay,
becomes a part of the request. Now this middleware can be connected to proxy. This middleware can be connected to the server also.
oh,
Usually middleware runs on the server, right?
yes,
So once you have reached the server, there is no role of proxy. Before you
oh,
reach the server, whatever you are doing is something which is carried out by the proxy. Proxy resides with the client, not with the server.
oh, okay.
The
It's a
proxy
client.
which resides with the server is something what we call as reverse proxy.
Okay,
Understand?
yeah.
Saket, Vivek is right.
Yeah. Yeah.
So does proxy use a certain kind of signature to identify her means himself that to the actual server that yes for that the proxy is being created. Uh,
It holds some information, and that information is the common interface between the proxy itself and the service. So as I
okay.
said, iMath interface in case of calculator application will be that common interface, or according to you, it will be the signature. Understand?
Correct. Correct. Yeah.
There has to be something in common, otherwise how the communication will happen, right?
Yes. Yes.
Means that interface is kind of contract. Means
Correct,
between.
correct,
Yeah. Okay. Means
correct.
that
So
we should follow the both on both sides on
absolutely,
client side and server side.
absolutely. So proxy has to follow that, client has to follow the same by asking for some kind of operation that is actually there in the contract. Proxy has the responsibility of providing the implementation of that contract to carry the request to the server, and server has to follow the same contract as well. Understand?
Yeah.
Okay. So let's see with implementation. It is the same project I have opened, rather solution that I've created earlier so far for all the other patterns. So again, it's a structural pattern. Let's right click on the structural folder and add new project. And let's give this, okay, first select console app, give this the name as 12 underscore proxy. .NET 5, create, and get rid of this console write line statement. Now, because we are looking to understand only the proxy concept, here we will not be actually building the client server application. Client server application requires complicated code to be written. We'll just focus on understanding what proxy is, proxy pattern is. Okay. So once we understand that, after that, if we create any client server based application, understanding proxies will be much more easier. Is it clear?
Yes.
So let's say here we have a class, which is an abstract class. And you can take this as an interface also, because abstraction is the most important thing. How you provide abstraction is not important. Whether it is with abstract class or with an interface, doesn't matter. Here I have a single abstract member, a method named as request. That doesn't return anything, just do some processing. Okay. Then I have the actual object. So let's say I call this as real subject. That inherits from subject. If it is an interface, it implements the interface. Let's hover on this using the light bulb arrow. Select implement abstract class, and your request method is automatically overridden there. Remove this throw new not implemented exception. For now, we'll just get a message displayed on the console. Real subject dot request method invoked. Now, this abstract class will be there with server. This abstract class will be there with the client also. This is the common point or signature, you can say. Whereas this implementation will remain only with the server. What actually needs to be done when request method is called lies with the server only. Even proxy doesn't know what needs to be done. Here goes the proxy class implementation. Let's say I name this as proxy. You can name it as subject proxy also, because it is ultimately proxying subject only. This also inherits from the abstract class or interface is implemented here, which means here also I need to say implement abstract class like this. But before this method, let's say I have a private member of type real subject into it. Proxy knows the server implementation, as I said. I mean, not exactly how the work is being done, but how to reach that particular operation which does the work. So it knows about the server object, and that's what we have created on line number 20. Let's remove this not implemented exception thing and replace it with some if statement. If statement again probably might be used for some sort of verification. Here, though I'm not going for verification, I'm just checking if real subject is actually initialized or not. If it is not initialized, I want to initialize it first. By doing this, I can put more if statements to do all the verification, all the authentication, authorization checks, etc. And once I'm done, here I can say place the call to request method of the real subject from here. Otherwise, I'll throw exception according to whatever the verification that has failed. So for example, if the authentication authorization check is failed, I can just throw the exception unauthorized access exception, right? Which will automatically stop this request method from being called from the server. Got my point? Then we go to the main method. Instead of creating the instance of real subject, I do create the instance of the proxy class. Proxy equals new proxy. Proxy.request I will call instead of calling the server's proxy or real subjects proxy, real subjects request method. And that's it. So client essentially need not know anything about the server. This is client, right? Let's start. So the output should be real subject dot request method invoked. And there it is. Yes or no? This is despite the fact that here we have not created the real subject instance, but the actual message is coming in a way that actually makes us feel that, okay, it is the real subject only which has been communicated. But typical proxy pattern behavior. Is this clear?
Yes.
I can get this done with the help of an interface as well. Let's comment this. Let's have an interface defined over here. Public interface iSubject, which has got void request declaration. This I'll comment, and rather I'll say real subject implements iSubject, which means there is no need of override keyword. I'll just copy and paste this line and comment the original one. I just remove override from here. I just have public void request. And similarly in proxy also I comment this portion and make proxy implement iSubject. Again, I cannot use override keyword here, so I copy and paste this line, comment the original line, and remove override from the copied one. There is no other change that I'm making over here. This is still the same. And I start this, I should get exactly same out. Have a look at this. Yes. So
Yes,
usually
Sanket.
with the client server programming, interfaces will be used more than abstract classes. Okay. Yeah, go ahead with the question.
So we have this abstract and interface to achieve this. So
Yeah.
what is the specific thing that in abstract class we should be using?
Can you elaborate further specific thing
No,
by that? What
actually,
do you mean?
yeah, these things can be achieved using interface or abstract class, right?
Correct, correct.
Uh, so then why do we have abstract class and as well as interface?
Okay, so your question precisely is why we have two options, right? Why not only interface or why not only abstract class, correct?
Yes.
Okay, so interface will contain only the method signatures, right?
Yes.
There will be no data associated with it. What if you have some data members which need to be operated on? And that data item, the data structure needs to be available both with the actual implementation and the proxy via proxy to the client as well. In that case, you will require the abstract class, as interface cannot have data members into it. Even the constants are not allowed in .NET. Yes.
Yes. So it means some kind of default functionality
Default
that.
functionality, you can say along with default functionality, you might want to have some data structure created which holds some data. So in all those cases where the data or default functionality is required, abstract class would be the need. Otherwise, interface is the way to go.
So if there are no static means the default functionality or some
Correct.
other, so we should be using only the interface.
Interface. Correct. That's
Yeah.
right.
Yeah, thank you for the clarification.
Yeah, welcome. So I hope this is clear to all.
Also, Saket, one more thing means
Yeah,
regarding this question as well means we on client side we can use the
yeah,
multiple inheritance using interfaces only, right?
correct,
Instead
correct.
of abstract. That's why means we prefer to go for
Yeah,
interface.
correct. So that's a very good observation actually, because we might want the single proxy available for communicating with different uh, services. As a facade pattern, we want to implement the proxy. Facade and proxy both working together. Instead of having multiple proxies created. Suppose I have 100 services, I would have 100 proxies created that way. So if I'm working with interfaces, there can be one proxy class which implements 100 interfaces, and then I need to work with only one proxy class instance. Correct?
Yes.
Okay. So that will be a combination of facade and proxy. Understood?
Yes.
Okay, let's move on to the next one, that is chain of responsibility, which comes under behavioral patterns. Now see, the difference is creational, structural, and design behavioral patterns, right? Creational is all about object creation. Structural was all about how the code is going to be placed and where. Behavioral pattern is more about exactly what the object is going to do, how it is going to behave, how it is going to respond to messages. That's why we call it as behavioral pattern. In that, the first one is chain of responsibility. Responsibility in itself is a kind of a behavior only. And then we are talking about chain. In general, what the meaning of chain is?
Linking between two. Link as a
Linking
link.
between two or more items, right? Now, in this case, imagine a case where there is a request being originated at the client side and dispatched. Now on server, to make it more scalable, we have implemented multi-threaded code. There are around 5 to 10 threads, each of which are responsible for processing the request on first come, first serve basis. Whichever thread claims the request should completely process it, right? This is something which will be required when we have too much of load on the server. Most likely our requests are going to be discarded if we have a single threaded implementation, the traditional implementation, right? We need to have multiple threads who will be taking care of the request. This is just like a branch of a bank. You go to bank, you want some of your account operations to be carried out. What do you see there these days? After the introduction of single window operations in all the banks, we can actually walk into any of the window which has got no load or less load, and we can get our request process there. Yes or no? Or probably there is a token system, or probably there is a guard who will ask people to go to a specific window. Yes,
Yes.
right? Same is the case with the passport office also, right? Hundreds of desks are there. Your forms, your formalities can be completed on any of those desks. Each desk is having the similar operation implemented. In some cases, there may be different operations also. But the thing is, each of them have the choice of handling the object request at any time. Whoever is free can handle the request. Yes, this is what we call as chain of responsibility. So suppose there are 10 windows. Each of those 10 windows are having the answer to your request. I mean, they know how to process, how to take it forward and provide the response. Now, where you go is decided by some logic, maybe token, maybe the guard sending you to certain window, right? With some prioritization. Most likely it comes down to tokens only. Yes or no? So you have more than one objects having chance to handle the request. This is chain of responsibility. This chain keeps on rotating and becomes available. One part of the chain becomes available to the object. Whichever part is available, that part will be handling the request and providing the response. Or else this just keeps on rotating, rotating, rotating. You can say the chain is of actually the request objects. Chain of request is created. It keeps on rotating until and unless some object picks one of the request and processes it. Until then, it will just keep on rotating. It is just like the queue which is formed, right?
Yes.
Let's have a look at the UML diagram for the same.
Saket, here we can relate to this to middleware, right? This.
Middleware cannot be related over here because each of the middleware component will have a different functionality, right?
Yes.
I'm talking about the same functionality.
Okay. Means it is just the same functionality and it is going to the
Yes.
another.
Yes. So
Okay.
it's just like having 10 servers and one load balancer in between where your request is getting queued, and the load balancer based on the load available on the server just forwards your request to one of the server. Now, it doesn't matter which server processes that request, the response will be the same. Correct?
Yes.
Right. So have a look at this. You have a client,
Yeah.
you have a handler, and then concrete handlers. Concrete handler 1, concrete handler 2, both will have the same logic, but which one gets the access to the object first will be providing the actual response. It could be 1, it could be 2. Next time again, if it was 1 first time, next time it could be 2 also. It's not guaranteed that if one object has given the response to one client, it will keep on giving the response for all the requests from the same client. Understood? So usually
Yes.
the load balancer implements this. Messaging based applications also implement this chain of responsibility, right? When you use message queues, your message lands in message queue, which can be termed as a chain. And then different clients are there who will be picking up that message from it. And one message picked up means it won't be available to other servers or other threads. It will be logged until and unless it is not completely processed. And once it is processed, it will be removed from the queue. Correct?
Yes. Means our lock object is also following the same inside the code.
Yes. Yes.
Okay.
So Sanket, I am confused. The
Yeah.
concrete, there are two concrete handlers, right? So both
Yes.
will be having the same functionality.
Same
Means so.
functionality.
Do we have the redundant code there, or how it will be?
You can say redundant code, but then there are reusability features also. You can term both the concrete handlers as probably two instances of the same class created on two different threads. Understood? So in
Yes.
that case, the code will not be redundant. Functionality will become redundant at runtime. Same
Oh,
functionality available via two different instances. Code will
yeah.
not be redundant in that case. So it all depends. Like both things are possible here. You might be looking for exactly same logic executing. At times you might have a requirement that okay, it's not the same logic. I have some variation in the logic. So I have two different handlers. Handler 1 does it this way, handler 2 does it that way. Understand? Logic may be different at times also, but all of them getting the equal chance of processing it. Like when I apply for a loan from bankbazaar.com, each bank probably registered with the Bank Bazaar gets the request. Yes or no? Whoever reaches me first, I'll probably proceed with it. I'm sorry. Yes or no? Now, how they process my loan request is their call. It may not be exact same logic. It may not be exact same process. But at the end, the response is I get the loan. You get it?
Yes.
Another example could be I'm looking to save the data in the database. Now, which implementation does this? I don't care. My job is to get the data saved in the database, right? So whether it's a .NET based implementation, Java based implementation, Node based implementation, I don't care. At the end, my data should be saved in the database of my choice. Got my point?
Yes. Okay.
Okay, so let's understand this with example. Here now, we'll collapse structural. Right click on the behavioral folder, add new project. What's our current sequence number? I guess 13, right? So console app, next. 13 underscore chain of responsibility is the name that I'll give. Next, .NET 5 create and get this console write line statement removed. Done. Here we have an abstract class. Handler. Here I create the instance of the type handler. I mean this class itself as a protected member by the name successor, which I initialize with dependency injection based on constructor. So I have not constructor, let's say method based dependency injection is there. So let's say I have public void set successor. I can do this with properties as well, like what we have seen before. I name this as successor. And then the body contains this dot successor equals to successor. Then I have the abstract member, public abstract void handle request, which is the actual request method, in fact, that for now, for example, takes in an integer parameter named as request, which you can say is the data to be operated on. And handle request is actually the method which allows some request to be created. Got it? I should have created this class before program. So I'll just cut this and put it here. By mistake, I put this as a member of program class. It's not the member of program class, it's an independent class. So just do the modifications if required There goes my first handler, public class concrete handler 1 inherits from the abstract class handler, overrides the handle request method. So I implement the abstract class, remove throw new not implemented exception, replace it with if statement, which checks if the request is greater than or equal to 0 and the value of request is less than 10, then do something. What is that? Displays a message on the console with an interpolated string. I say curly brace, this dot get type. So whichever object is there, get the system type of it. From that, get the name of the type. Space after the closing curly brace. Handled request. Space curly brace within curly brace. I put request, the integer parameter itself. Else, if successor is not equal to null, then successor dot handle request. So what I'm saying is concrete handler 1 is going to handle the request if the request value is between 0 to 9. What if it is more than equal to 10 and let's say less than equal to 20? I want concrete handler 2 to take care of it. Kind of a load balancing only I'm doing. Let's copy this concrete handler 1, paste it here, change the name to concrete handler 2. Structurally, it will be the same. Here I say if the request value is greater than equal to 10 and less than 20. So 10 to 19. This is concrete handler 2, which will handle the request. Rest all the things remain the same. So some changes, but some redundant code as well, where this redundant code can be moved into a separate object altogether. Maybe you can promote it to your abstract class handler, where you can create a protected method, right? Which contains a common code, like this if statement.
Sanket, here the 42 line.
Yeah,
So successor dot handle request. So
yes.
which method it will call?
See
42 success.
here in the handler base class itself, we have got a method called a set successor, right?
Yes.
This needs to be called somewhere, which will set up which handler object it is going to be. Is it concrete handler 1 or is it concrete handler 2? So technically, when this handle request comes in from concrete handler 1, it will be on concrete handler 1 request method only. This one only. It's a
Okay.
recursion. Similarly, when it is being called from concrete handler 2, it has to be this one only. Again, recursion. Understand?
Yes.
I copy this class concrete handler 2 and paste it once more. Handler 3 I'm going to create now. So let's rename this to handler 3. This is going to take care of the request if the request number is greater than equal to 20 and less than 30. This is load balancing logic, a kind of load balancing logic, isn't it? Okay.
Just
Yeah.
yeah, means at the single time it is holding only one object of
True.
concrete and or
That's what we discussed, right? Out of multiple implementations, one object will get the access to the request. Not all, but all will have a chance, right? Probably all will
yes,
get the chance, but execution will happen for only one.
one
If suppose
means
the value is 25, concrete handler 1 will say it's not my thing,
mhm,
right?
yes,
Because it doesn't fall in the condition, correct?
yes,
Similarly, concrete 2 handler or concrete handler 2 will not take it because it doesn't fall in the condition. Concrete handler 3 will say, yes, this is mine. I will handle this. Let me take care of it.
mhm.
So it will hit all three handlers, but will be handled by only concrete handler 3 when the request value is 25. Understand?
Okay. Means from client side it is having the means right now handle is our abstract class, right?
Correct.
And it is pointing to means at runtime it will decide means
Yes,
which one to exit. So
absolutely.
it can hold three it can refer to the three object as well at runtime, but
Correct.
depending on request count it is deciding means which one to call.
Yes.
Okay. Yeah.
Decide it randomly at runtime. So here I say, let's create the instance of handler h1. I cannot say new handler, right? Reason handler is abstract class and which cannot be instantiated. So here I say it is actually holding the instance of new concrete handler 1. Same way I'll create total 3 objects h1, h2 and h3 respectively of type concrete handler 1, concrete handler 2 and concrete handler 3 respectively. Then I say h1 dot set handler or set successor h2. For h1 it is h2. For h2 I'll say it is h3. And for h3 there is nothing. No successor is there. So here I am actually now building a chain. That first it is h1 which will be called. H1 will give the call to h2 handle request. H2 will then give the call to h3. So that way I said that all will get the chance, but only one of them will finally handle it, depending on what is the value of the request. Got my point? H1 chain to H2, H2 chain to H3. On line number 70 and 71, it is visible. S3 is the last node, it is not chained to anything. So it becomes null, right? There is no successor to H3. And that's why the second else if statement is there. Here I say there is an array of type integer by the name requests, which is initialized to some integer values. Let's say 2, 5, 14, 22, 18, 3, 27, 20. Some random values I have given, right? And then I just iterate on this for each int request in requests. h1 dot handle request. I give the first chance to h1 only because that is the beginning of chain. And I pass request parameter to it. So for 2, what will happen if the first value is picked up 2? h1 dot handle request. So h1 is instance of concrete handler 1. It goes to concrete handler 1. The value is 2, right? So it falls in this condition. It just says this dot get type dot name. So practically it is going to show me concrete handler 1 handled the request 2, right? And that's it. It will not go here. Yes or no? It's else if. So if this condition is satisfied, this condition will not be touched. Yes or no? What is the next value?
Yes.
What is the next value in the array? 5. It is the
5.
same thing. Same thing. Falls under 0 to 10, right? So from h1 only it will come out. Then is 14. Goes to h1 only. Here it checks the condition. If request is greater than equal to 0, that's okay. But with AND operator, we are checking request is also less than 10, which is not. So it returns false. Then it checks if successor is not null. Now h1 dot set successor h2 has been set. That means successor is already having h2 into it. So technically, what this statement converts to is h2 dot handle request. So 14 goes to now handle request of concrete handler 2, which falls in this range. So it displays concrete handler 2 handled the request 14. And it doesn't go here to h3 because h2 already handled it. Next value is 22. What happens here? Again, it begins from h1. Is it in this range? 22? No, it goes here. Calls h2 dot handle request 22. It comes here. Is it in this range? Not again. So it goes to this else if. h2 dot set successor s3 we have already said. So successor is now s3. s3 dot handle request 22. It comes here. It is in this range. Yes. So it displays concrete handler 3 handle request 22. Got my point? Back to 18. This will be handled by handler 2. This 3 will be handled by handler 1. This again will be handled by handler 3. And this will be handled by handler 3 again. So handler 1, handler 1, handler 2, handler 3, handler 2, handler 1, handler 3, handler 3. Let's verify this by running it. Handler 1, handler 1, handler 2, handler 3, then handle 2, handle 1, handler 3, handler 3. That's what we discussed, isn't it?
Yes.
Yes. Means means when it goes to the last handler, it will be kind of recursive call till that level. Is it?
Correct. Correct.
Okay.
And what if I have a value like 35 also into it? What will be the output here?
It will be null will be there.
It will just be ignored
Yes.
because there is no handler for it, right? No taker for it. Got my point?
Yes.
Understood?
Means just want to know performance wise is better to handle by first handler, right? Means uh,
Uh, yes, in terms of memory utilization, if you're talking about, yes, you are right, but not much on performance side. But yeah, memory utilization indirectly affects the performance. Okay,
okay. Mhm.
is it clear?
Yes. And is there any means we are right now just chaining the handlers means kind of.
Correct.
So is there any restriction how much we can chain it
No
that
restriction, no restriction. The length of chain can be n.
Okay.
Infinite chain you can create, but practically it will depend on your business request or the domain, right?
Yes.
Okay,
Sanket,
like
can you?
when you are dealing with a bank and you are looking for a service, if the person whom you interact with is not from that department, he what he will do, he will not say no to you. He will say, I'll check with my uh, colleagues if someone can help you out. He will connect you to next person. Again, after analyzing, if that person also finds that this is not his thing, he will further forward it to someone else. This will keep on happening until and unless it reaches a stage where either it gets processed or the last person in the chain says that, okay, this cannot be handled by this bank. Yes or no?
Yes.
Yeah, go ahead.
Can you go back to the code, Sanket?
Yeah, sure, sure. Yes,
So here in the for each we are only calling h1 dot handle request.
correct, correct.
Uh, what about this other analysis? How it is getting executed?
Yeah, that's what I said. When it is, let's say, case number 3, the value is 14, right? So h1 dot handle request 14 is the call. Where it lands up here. What this request says or this if statement says, it is false. 14
Yes,
is greater than equal to 0, but not less than 10, right?
yes.
So this is false. Where it goes?
Else if
Then it checks if successor is not equal to null. Now, from where the successor is being set, here we are doing it. H1 successor is whom?
h2.
H2. So what does it mean? When I say if successor is not equal to null, that means I am checking H2 is not equal to null, which is not. So it says successor dot means H2 dot handle request, right?
Yes,
Here is the call to H2. Now, when it is 22, what is happening? H2 also says I am not going to handle this. Then it goes to H2 successor, which is H3 as per this. H2 successor is H3, right?
yes, yes.
So from here, the call to H3 is placed. And when it is 35, H3 also says, okay, I cannot handle this because it doesn't fall in my range as well. Yes or no? It just
Yes.
ignores that because there is no further else statement, termination statement, right? If I want, I can have a termination statement also with another else block, right?
Yeah.
So I hope this is clear. Better you do a debug execution, I mean, with breakpoints, you will get the flow like what we discussed or was what we saw at the previous session. Understand?
Yeah, Sanket. Thank you.
Okay, so time for a break. We'll be resuming the session by 11 and we'll be then moving on to the next pattern, that is command. Okay.
Yeah, sure.
Hey guys, I'm back. Shall we proceed?
Yes.
Okay, so let's proceed to the next pattern, that is command. By name, it looks like giving command to something, right? Ordering
Yes.
something, correct? So somewhat related thing. Practically what it does is it encapsulates your request in the form of an object so that you can parameterize the clients with different requests. The same request basically with different parameters can go to the server and can do multiple operations. This could be quite useful when you are working with the messages based application or messaging based applications. So queues, if you are making use of, or some sort of request logging, if you're doing, that's where it could be useful. And this results in a one-way kind of communication. One-way communication in a way also says that, okay, whatever operation you are carrying out, it is something which will be uh, undoable. Means you can reverse that action by calling some other action as well, right? You can perform undo. Okay, so let's see the diagram first of all for it. Here we have client. There is a command in between, which will be an implementation of something called as invoker. There is concrete command, which will be having the implementation of the operation, which will be called on the receiver. Command will be an interface, which implements invoker again, right? Okay, so let's go ahead and see with example. Let's close this and on behavioral, I'll add, right click, add new project, console app, next, 14 underscore. Command is the name for the project. Next, .NET 5, create. Let's remove this console write line statement. And then first I'll create the abstraction for command, which can be abstract class or interface. As I said, abstract class command contains the instance of protected instance of receiver, the class which we have not created yet. Let's say this instance will be named as receiver only. Here goes the constructor, which will be parameterized, that will receive the instance for, as a dependency. So receiver, receiver, and what I have here is this dot receiver equals to receiver and the abstract member going in here. Public abstract void execute. The receiver class needs to be there in place. So here, just before command class, I create public class receiver, which removes the error. What it has got is the actual action, public void action. And for simplicity, we just say it has got console write line statement, which says receiver dot action invoked. Okay. Now This abstract class command needs to have its implementation as concrete implementation. So here we go and say there is a class concrete command that inherits from command and implements the abstract members. So here we implement abstract class. Before that, we need to have a parameterized constructor that chains to the parameterized constructor of the base class. This takes in receiver, receiver, and chains it to the base class constructor by calling base class here, base class constructor here. Okay. What this execute method contains is, let's replace this throw new not implemented exception with receiver dot action. And as per the diagram, there is one more entity which is pending, that is invoker. Here we say there is public class invoker, which contains the instance of command class, the abstract class, a setter method, which sets up the command. So here I say set command, public void set command, takes in command as parameter, and sets this dot command to command. Then we have public void execute command. Which simply says command dot execute. Which ultimately calls receiver action only. Okay. So at the end, if you see this way, I can build a sequence of commands which will be carried out on the object one by one based on the parameters. Okay, so let's complete this by setting up our main method as well. First, I instantiate the receiver. Receiver equals new receiver. Then I instantiate my command. New command is not possible here as it's an abstract class. Hence, I say new concrete command, which takes in receiver as the parameter. And then invoker, invoker equals to new invoker. On invoker, I call set command. Pass the command object to it. And then I say invoker dot execute command. Now just look at the flow. Execute command comes over here. It says command dot execute. Which command? This command set over here in the previous line, which is that concrete command. So concrete command is here, which takes in receiver object, which receiver, the instance of the receiver class. And what execute method actually is doing is calling action method. So ultimately, this is what which will be called. Right now, in this, I can actually have multiple actions configured. So let's say this is action 1. I can have action 2, action 3, action 4. All can be executed in a sequence on the given object, where I just, as a client, I just need to call execute method. This execute method will contain the call to different actions. As a client, I need not actually have different calls to the different actions independently. I call the execute method, which does rest of the things. So for me, only this is what which will be important. Understand? Understand? Like on Amazon, I buy something, I pay for it. After that, it's Amazon's duty to communicate with the seller, to transfer the payment to the seller, to collect the ordered item from them, and get it reached to me. Yes or no? Whatever different operations are required, that those operations are carried out by Amazon. I don't need to do anything apart from ordering the item. I'm not responsible for finding out the seller address and going there and picking up my item. Correct? I don't need to find out the warehouse of Amazon also. Correct? So that's what command object is. Okay? Or command pattern is. So is it clear to all?
Yes.
Yes.
I have put only one action, but in practice, there can be a series of actions which can be placed into it, right? Like I might have a calculator program and I want just one method to be called where I want to pass two parameters, two numbers. And then I want to just say, okay, compute. Now, when I say compute, it should be plus, it should be minus, it should be asterisk, it should be divide all together. Or I can parameterize that also. In compute, I can pass a character parameter, which basically contains the symbol of plus, minus, asterisk, or slash, defining which action actually I want to call. Got my point? And apart from this, I can have undo and redo actions also. So when I say undo, there also I can pass parameters like which all actions I want to undo or which all actions I want to redo. Undo without parameter, probably it is one last action which needs to be undone. Same is the case with redo. If I say undo 5, means last 5 actions needs to be undone. So probably some compensation logic needs to be executed. Like I transferred funds to 3 different people and I say undo 3. What it means? That fund transfer has to be reversed. Is it clear? Yes. Any questions on this? Fine. So let's move on to our next pattern, interpreter. What do you understand by the name? What is interpreter in general? Usually used with some language, right? Its main intention is basically to understand one statement at a time and provide the action on it. Yes? In which context it is being used, depending on that, the action will be decided. Whether it is an action or whether it is just transformation, translation, depends which context being used. Right? Like if I talk about programming language interpreter, what it does, it understands one statement at a time and translates it to machine understandable code, and then it gets that code executed immediately. Yes or no?
Yes.
So make something understandable. Make the statement, make the sentence understandable depending on in which context it is being used. That's what the interpreter is all about. Let's have a look at the diagram. Here is the client. Here is the context. I said it is always based on the context. You have the abstract expression, which represents all the types of expressions. There is interpret method into it. There is terminal expression. There is non-terminal expression. So suppose if we are talking about a human understandable language, it's not programming language. Then terminal expression would be something like where I have full stop. Non-terminal expression will be any word in the sentence, right? So whether it is the end of sentence or not, to understand that, probably I need to have different expressions, which will be ultimately aggregated into abstract expression, and the client will be interacting with it only, right? And the context will be provided by the client. If it is a programming language, there also somehow this is going to be applicable. Like in C sharp, semicolon is the end of the line, end of the statement, right? So that is terminal expression. Anything else is non-terminal. Understood? So let's create an example for this. Right click on behavioral, add new project, console app, next, 15 underscore interpreter is the name I'll give, next .NET 5 and create. Remove console write line statement from main. And here we are actually going to use collection of the expression. So I'll go for importing system.collections.generic. Okay. And then some series of classes starting with the user provided context. So first of all, I have the class context. For simplicity, I'll not put anything into it. I'll just keep it blank for now. Then there is abstraction for the interpreter, abstract expression, let's say. Public abstract class. I'll name this as abstract expression or expression base, whatever you would like. Here I have the abstract member, public abstract void interpret, which takes in the context as input. And based on the context, it provides interpretation. Okay. Then there is a class which implements this abstraction. So let's say public class terminal expression, first of all, that inherits from abstract expression. And let's implement the abstract class so that I get the abstract member added. Remove throw new not implemented exception and replace it with console.writeLine statement, which reads terminal dot interpret method invoked. And then I copy this class, paste it back. I call this as non-terminal expression. And here I say non-terminal dot interpret invoked. Okay. Then let's go to main. Here we'll create a context. Now, if you're looking for language interpretation, most likely it will be an object representing all the data in the form of a tree data structure. So left hand side, right hand side, there will be two nodes applicable to the root node. Then each of the node will again have LHS, RHS, and something like that until and unless it reaches the terminal. If you have worked with data structures, you can understand it. Then I have list of abstract expression type. Let's say named as list equals to new list of abstract expression. I'm using the base class over here. So practically the member can be terminal expression or non-terminal expression, anything. There comes the use of covariance, right? I say list.add new terminal expression. List.add new non-terminal expression. Then again list.add terminal expression. New terminal expression. One more terminal expression. And then I have one more non-terminal expression. So total 5 objects I have added. And then I iterate using for each abstract expression in list. Here I say expression dot interpret the context. Save and start. So output will be simple. Here, when it reads the first item, terminal expression type, it shows terminal dot interpret invoked. Then non-terminal dot interpret invoked. Then terminal dot interpret invoked. Again terminal dot interpret invoked. And then finally non-terminal dot interpret invoked. Right, so this list itself is representing the tree structure. And the current context is being picked from one item of that particular node. So you can say context for now is representing one node of the tree data structure, right? Understood?
Yes.
Most likely here one of the example that comes to my mind will fit into picture. Like if you are converting your number in words to a number, or number to number in words, like 1,29,560, 563, say for example, you will need this. You have to pick one digit at a time, find its place value, and accordingly you have to convert it to word. Yes or no? So interpretation will be required. Yes or no?
Yes.
Number to Roman number to number will also require the similar thing. Correct? Okay. So that's interpreter, mainly for language processing. Let's move on to the next one, that is iterator. This is easier. We recently used this in our last example itself. For each actually implements iterator pattern on it. Right? Iterator means what? Repeat something until and unless there is nothing to process further. So there is one example that we have discussed in the past as well. That interview scenario we discussed, right? One person being interviewed, there is another person waiting just outside the cabin, and there is crowd in hundreds or thousands waiting outside. So the most effective way is this only, where there is one person is waiting outside the cabin. The first person, interview completed, sends the next person waiting outside the cabin in, and while going out, he sends one person from the crowd to wait outside the cabin. And this goes on until and unless there is no one left to be processed. Yes or no?
Yes.
That's iteration or iterator pattern actually. Provides a way to access the elements of an aggregate object, which can be an array or a collection, sequentially without actually exposing its underlying representation. What it contains and what it does is not something that iterator depends on. Here is the diagram for it. You have client, here is the aggregate object on which create iterator being called. So this can be get enumerator method in our .NET example. There is iterator which gives me the navigation first, next, previous, is done means is there any further item to be processed, get current or current item. Right. So there is an abstraction, there is a concrete implementation for it. And for aggregate, there can be concrete aggregate as well, if this is an abstraction. Right? So let's understand this with an example. Right click behavior, add new project, console app, next. Sequence number is 16, right? So 16 underscore iterator. Next, .NET 5, create, get rid of this console write line statement. And we are looking for aggregation. So definitely we'll need the namespace system.collections.generic to be imported, which will provide us the list aggregation or maybe some other kind of aggregation. Even the iterator thing, get enumerator, get or similar things will be provided by this only. There are two interfaces usually which does that, IEnumerator and IEnumerable. Correct?
Yes.
Both of them come from this namespace only. Okay. So let's say here I have my first class, public abstract class aggregate. Has got one abstract member into it. Public abstract inter or iterator named as create iterator. This is just another example that we are building. Practically, we need not do this in case of .NET because this job is already being taken care of by IEnumerator method and IEnumerable, IEnumerator interface and IEnumerable interface. You already have getEnumerator for this, which comes from IEnumerable, right? But yeah, to understand the overall concept, we actually build one of our own. Iterator doesn't exist as of now. So let's create the class iterator or interface. If it is completely abstract, it can be an interface also. So IEnumerable is actually an interface. Here I'm going with class, abstract class. Let's say I have iterator abstract class over here, which has got the members for navigation. So public abstract, what it returns is an object because it can be of any type. I can make it a generic interface or generic class also, right? So instead of object, I can put generic type. Then I have public abstract next. You can have all other like previous and last methods also into it if you want. Then I have public abstract object, or let's say bool is done or is completed. Just to check if there is more number of items to be processed. Then I have public abstract object current item or get current method. Terminology can be different. The terminology which I'm using right now is not .NET specific. This is more generic, used anywhere across languages, right? Get current is .NET terminology for current item. Next is actually represented as move next in .NET. Got my point? Now for iterator, I have a concrete iterator as well. Let's say there is a public class, concrete iterator. This is just like a class. You can assume that implements getEnumerable and getEnumerator both, and then provides the iteration on the aggregate object. So here is the aggregate object, concrete. I'll say aggregate. You should create this class first, in fact. So let's cut this from here. Ideally, position doesn't matter, but for our easy understanding, I'm moving it to a different location. So before I actually complete this, let's create the concrete aggregator first. Okay. So here goes our public class concrete aggregate that inherits from aggregate. Let's implement this abstract class. Now, before I actually implement create iterator, I first of all build the aggregate object, list of object named as items equals to new list of object. And then in create iterator, I remove this throw new not implemented exception and then return new concrete iterator for the current object. This. Okay. Now, usually while working with iterators, we keep track of count also. Like how many items are there. Let's say public int count. There is a read only property. Hence I say get return items dot count. And then there is a indexer object I create over here, indexer property. So which makes it possible to allow us to use the list object as array. So with the subscript operator, you can use it. You can access the members. I say public object this square bracket int index, which has got its own get of items of index. And same way here I have set items index comma value, or I can actually look for a better option. Items dot insert method I'll call index comma value. List already contains the insert method into it. Right. So whatever index I've asked for uh, being updated, I say insert the item at that index. Got it? And then comes the concrete iterator class. As here also you can see there is an error. Here also there is an error as the abstraction has not been implemented. Plus there is no constructor which accepts the parameter. So that's the issue here. Let's see what it suggests. I'll say implement abstract class iterator. So we have current item. This error is resolved. And then there is one more error for the constructor that is pending. For that, first of all, here I create a member item concrete aggregate by the name aggregate. To keep track of which item is being currently processed, I say there is current variable which is set to 0 to start with. Initially, it will be 0 only. And there comes the constructor now. Concrete iterator that takes in instance of concrete aggregate and sets it to this dot aggregate. Okay. So before I implement current item, in fact, there are all methods here. Current item first is done next. Let's implement all of them one by one. First, I'll code for the method first. Remove throw new not implemented exception. And let's put return aggregate of 0. This is what I was talking about, array-like accessing, right? Using subscript operator, I can access the elements. So first element is 0th indexed. Next, I'll go for the method next. Let's remove throw new not implemented exception from here. Let's create local variable object as return value. Initially set to null. Then comes a if statement, which checks if the current value is still less than aggregate dot count -1. Means I am in the indexes, available indexes. Then I can have a return value. I set ret equals to aggregate of plus current, so that the current item is advanced to the next item, and then get the value. And there I say return ret. Okay. It is move next, right? So I have to give the next value from current. Next, I code for the current item. So remove throw new not implemented exception from here. Current item is always going to be the current position. So I can directly say return aggregate current. So whatever is the value of current from that index, the value needs to be returned. And then is done. Remove throw new not implemented exception from here. It will be simply the result of a Boolean expression, which I can directly return. Current, if the value of current is greater than or equal to the count, that's what I want to return. If it returns yes, means is done will be true. If it is false, that means there are more items to be processed. Correct? This is what your get enumerator and get enumerable together do. Is it clear? By default, you have the iterator pattern implemented at the framework level itself. That's what I said. Whenever you are working with frameworks, there are many design patterns which are already in use. Is it clear?
Yes.
Let's instantiate concrete aggregate here in main. Let's say I name it as A equals new concrete aggregate. Then A of 0, I set to item 1. 4 or 5 objects I add here. Let's say this is A1, this is A2, this is A3, this is A4. And likewise here, this is item 2, item 3, item 4, and item 5. Then I want the iterator object to be created. So here I say iterator I equals A dot create iterator. This is just like calling get enumerator. Then a message iterating over aggregate public collection object. With a new line character at the end. I say object item equals I dot first. This gives me first element. And I go for a while loop item, while item is not equal to null, console.writeLine the value of item. I could have used do while otherwise. And in that case, this object item equals to I dot first, I would have done in the body of the while loop, right? Now, in between, I have to advance also. So I say item equals to I dot next. Otherwise, it will be an infinite loop. And then start. So it should display me item 1, item 2, item 3, item 4, item 5, and then finished. I hope everyone understands how IEnumerator and IEnumerable interfaces actually do work. Yes or no?
Yes.
Clear? If you have worked with those interfaces in the past and if you know the functioning of for each, you can easily understand what's happening here. This is more generic implementation without a language dependency. So this is not actually the .NET version. .NET version is more simplified. But yeah, logically, it does the same thing behind scenes. Understand? Yes?
Yes.
Great. So let's move on to the next and the last pattern for today's session, which is mediator. Any idea what mediator in real life means? Mediator, broker. Provides. Yeah, go ahead.
Yeah. Yeah. So when the two different objects, can't communicate, so it's create a synchronization between two objects and communication can occur.
Correct. So there is one common object in between. Both of the objects will talk to that object for passing on the message to the other, right?
Yeah.
Something where we are looking for some kind of brokered architecture. We use mediator.
Yep.
Right? What
Yep.
it provides ultimately is loosely coupled implementation, right?
Yep.
So in a way,
Yes.
it avoids the two objects from referring to each other directly or explicitly, which means the two objects can evolve independently. Their interaction can also evolve independently. The two objects can be created and managed and maintained by two different teams or two different people. Correct?
Yep.
Here is the diagram for this. So this is the actual object and this is the mediator object. Right? So any communication that needs to happen will happen via mediator. Understand? Let's
Yes.
understand this with an example. Back to Visual Studio. Let's add another project here to behavioral console app with the name 17 underscore mediator. .NET 5 create. Remove console write line statement from main. And then here we have our public abstract class mediator. Why abstract? Because that promotes the loose coupling, correct? the evaluation can happen over time. Here I have public abstract void method by the name send, a parameter called as message of type string, and then another parameter of type colleague, where colleague is going to be a class that we will write shortly. But now I'll just ignore that error. Here goes the concrete mediator class. So let's say public class concrete mediator that inherits from mediator. Implement the abstract class. Automatically introduces the send method. Now before that method, here we have instances of the other two classes, concrete colleague 1, let's say named as C1, and concrete colleague 2 named as C2. Again, these two classes will be creating shortly. Then we have a write only property of type concrete colleague 1 by the name colleague 1, which has got a set block which sets C1 equals to value. I copy this property and create one more for colleague 2. So just 3 changes. The type changes to colleague 2, name changes to colleague 2, and set block set C2 equals to value. Okay. And then remove throw new not implemented exception statement from send. Replace it with if colleague is equals to C1, C2 dot notify message. Else C1 dot notify message. So basically, when I'm calling send, there is one colleague sending message to colleague 2. Another colleague means. Now C1 to C2 or C2 to C1. That's what the logic is. Understand? So now there are few pending things like colleague class is not yet created, which is supposed to be an abstraction. Then concrete colleagues are not created. So we'll write them first. So here goes the abstract class, first of all, by the name colleague. Okay, missed the class keyword. Let me put that. Right. So the first error is gone here. Colleague does exist here. And then what it contains is a protected member of type mediator by the name mediator. and then contains a constructor which sets up this mediator. So here goes the parameter mediator by the name mediator, and the body contains this dot mediator equals mediator. That is your abstract class colleague. Right now, concrete colleague 1 and concrete colleague 2 needs to be built. So here goes public class concrete colleague 1 that inherits from colleague, the abstract class, implements it. Yeah, so there is no abstract member, so there will be no implement abstract class option, but we do need a constructor. So I just say implement constructor, and there it automatically introduces it. What it contains is a method send. String message as the parameter. And what it does is it just calls mediator.send method, passes message, comma, current object to it. And then it contains notify method. So let's say public void notify. What to be notified is the message. So string message. And for now, to keep the thing simple, I just use a console write line statement to display interpolated string. Colleague 1 gets message colon curly brace message. Same thing I'll copy. Concrete colleague 1, the whole class. I'll paste it here and make simple changes here, like this will be colleague 2. The constructor name also changes to colleague 2. And further here it says colleague 2 gets the message. And then the main method. So here we go and create the instance of concrete mediator. Mediator equals to new concrete mediator, followed by concrete colleague 1. C1 equals new concrete colleague 1 with mediator object being passed to it. Then I say concrete colleague 2, C2 equals new concrete colleague 2, mediator object going in it. Here, the two objects which want to communicate with each other with the brokered architecture are C1 and C2. And for that brokered communication, they use the intermediate object called as mediator. Here I say set the colleagues for both of them. So I say mediator dot colleague 1 equals to C1. Mediator dot colleague 2 equals to C2. Mediator should know which two objects it is going to provide the communication for. And C1 says C1 dot send. How are you? Actually, it is C2 which is sending the message to C1. How are you? Then C2 sends the message. Fine. Thank you. Okay. C1 calling its own method, C2 calling its own method. But ultimately, this method uses mediator to pass on this message to its colleague. Because C1 has no knowledge of C2, C2 doesn't have any knowledge of C1. They cannot communicate directly with each other. It's a mediator which knows both of them. C1 has sent the message, how are you? Colleague 2 received it. C2 has sent the message, fine, thank you. Colleague 1 receives it. Yes?
Yes.
Now, when you make use of a message queuing, the message queue itself is the implementation of mediator pattern, isn't it? One application puts message into the queue, the other application reads it on its end. Yes or no?
Yes.
The queue itself is an example of mediator pattern, correct?
Yep.
Any questions?
No. No.
Great. So that is it for today. Tomorrow we'll be ending up with the design patterns. 6 more patterns we'll be learning, named as memento, observer, state, strategy, template method, and visitor. All behavioral patterns only. Right? Tomorrow means the next session, Monday. Okay?
Okay.
Yes, yeah.
So I hope you enjoyed the session and understood all the 6 patterns we have discussed today. Practice everything. You have got weekend in between. So not only what we have learned in today's session, revise everything right from the day one, whatever we have discussed and seen, and see if you have any questions. We'll take up those questions first on Monday, and then we'll move on to the next set of patterns. Got it?
Yes.
Okay, then. Have a good day. Have a good weekend. Come refreshed on Monday. Thank you.
Thank you.
Thank you.
Thanks.
Thank you.
Thank you.
Thank you.
Thank you.